Welcome to today's lesson. My name is Siamasaka Kirendens. Today I'm going to take you through organic chemistry, and in particular, we'll look at alkenes. We'll look at actually how we can name them, how can we write the general formula, and how we can write the molecular formula as well as the structure formula. This is very important because this is the basic concepts which will help us actually to do more complex problems in organic chemistry. And so we proceed to the lesson. As I indicated, today we're looking at organic chemistry, and in particular, we are concentrating on the alkenes. As you are aware, alkenes are actually hydrocarbons, meaning that they only contain carbon atoms as well as hydrogen atoms. And so they are also saturated because they are able to actually take on more carbon, more hydrogen atoms because of the nature of having double bonds, as we will see in details in the just coming actual slide. They are also can be named by actually ending them with the ENE, as you can see from our kin, we have E and E. So when naming them, they end with the ENE. Then we'll look at how we can write the molecular formula, which we are going to generate from the general formula, and then we'll be able to write also the structure formula. Okay, and so the hydrocarbons, as I indicated the area, actually contain carbon double bond, that is the alkenes. There will be one at least the point where you're going to have a double bond between two carbon atoms. This is a very important concept to understand. A meaning the one. And they are saturated actually, as we indicated, because they are capable of combining with more hydrogen atoms. So the general formula for alkenes is actually as follows. We have CnH2n. C here actually stands for carbon, and N is the number that we are going to have for that carbon atom. And then we have here 2 times N. And so this is actually the general formula. It has to be actually known because for us to be able to proceed to name the alkenes, we need to know the general formula. And so, for example, if we are to give a name to the simplest alkene, actually is ethene. We cannot have methane because always, as we indicated earlier, we need to have at least one double bond between a carbon atom and another carbon atom. And methane has only one, and therefore it is not existing as an alkene. So the alkene starts from actually ethene, meaning we need to have 2 carbon atoms and then 4 hydrogen atoms. How do we get them? We get them from the general formula. Here we're going to have 2, and then 2 times 2 gives us actually 4. And propene also, you notice that it's ending with the ENE, and then the carbon atom will be 3, and then 2 times 3, that will be 6. And then I will not do number this one, I will go straight into pentane. Also pentane ending ENE, and then you are going to have 5 here. So meaning 5, and then 2 times 5, that will be 10. So this is actually basically how we can actually name the alkenes, and then we derive the molecular formula using the general formula. So it's important that again we reflect on the general formula because it helps us actually to name. And we said actually end with the ENE, that's the alkenes. Now we proceed on to look at how we can actually write the structure formula for these alkenes. And as we stated earlier, the simplest alkene is actually ethene. And meaning that we said there should be a double bond between the carbon-carbon bond, at least A, meaning one. And here we have only two carbon atoms. So we're going to write two carbon atoms with double bond. So meaning there are 4 electrons here. And meaning that around this carbon atom, I only remaining 2 bonds, one there and one there. Doesn't matter, even if this bond is brought this side, doesn't matter, as long as there will be actually 4 around the carbon atom. Similarly here, 1, 2, 3, 4. There are 4 around the carbon, the bonds, and each bond has how many electrons? 2 electrons, meaning that for carbon actually to attain a stable configuration in the outermost shell, it means it should have actually 8 electrons, while hydrogen should have actually 2. So basically, this is how I write the structure formula for ethene. Similarly, here, the first thing you need to write when you're writing the structure formula is to write the number of carbon atoms. So you start, you put the 1 there, 1 double bond, put there, and 1, another one. And then around this one where they are double bond, then you put here hydrogen there, and then here hydrogen, and here hydrogen, meaning there will be 1, 2, 3, 4. Even here will be 1, 2, 3, 4 around this one. So around this one there should also be 1, 2, 3, 4. And then you put the 6 hydrogen atoms. So this double bond does not matter. If you brought it to this side, you start from this other side where the carbon is ending to actually have the same name. Next, we look at actually butane, but this one is a bit different because actually we will not start the carbon atom double bond. Actually will move from the first one to the second one. So as we indicated earlier, you write 4 carbon atoms. So write 1 there, double bond, carbon, bond, carbon, and bond. And around each of these carbon, you write 4 bonds. 1, 2, 3, 4. Around this one, 1, 2, 3, 4. Around this one, 1, 2, 3, 4. Around this one, 1, 2, 3, 4. And then wherever there is a bond, we can put the hydrogen atoms. And there should be 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. So this one is on the first, so even the naming, it is but. Instead of saying butane, say but 1 ENE. Said the end in ENE. But 1 ENE. So it doesn't matter if this double bond was actually put on the first one here. It will have the same actually naming. We proceed to the second one. Now the double bond here has shifted to number 2, carbon number 2. So write 1 carbon there, 1 bond, carbon, 2 bonds, carbon, 1 bond, and 1 carbon. And then around each of these carbon atoms, you put 4 bonds. 1, 2, 3, 4. 1, 2, 3, 4. And this one, 1, 2, 3, 4. And this one, 1, 2, 3, 4. And so we have to name it as but 2 E and E. So ensure that there are 8 actually hydrogen atoms. So you can count them 1, 2, 3, 4, 5, 6, 7, 8. So it doesn't matter where this carbon double bond is. Starting from this side, it's on carbon number 2. Starting from this other side, it's on carbon number 2. So it has the same name. So these hydrogen atoms, if you want, you can write them down there, and then these can be left blank. It doesn't matter as long as there are 4 bonds around the around carbon. There should be 4 bonds around the carbon atom for each of them. Then we proceed to the other one, which is pentane. It should have 5 carbon atoms. So write 5 carbon atoms, 1, 2, 3, 4, 5. Then put a double bond on the first one. You can choose either from this side or this side. The first one, 1, 2, 3. Put that one, put that one, put that one, put that one. And then around each of them, there should be 4. So we have 1, 2, 3, 4. Then put hydrogen there, put hydrogen there. Then around this one, there will be 1, 2, 3, 4. You put a hydrogen there. This one will be 1, 2, 3, 4. You put a hydrogen there and you put a hydrogen there. This one, there will be 1, 2, 3, 4. The hydrogen there, the hydrogen there. And this around, there will be 1, 2, 3, 4. Put hydrogen there, and hydrogen there. So this is actually only carbon number 1. If you wanted, you could put it from this other side. It can be here to still have the same name. And you said they end with the E and E. So this one will be pent 1 E and E. Okay, so the second one is that we have shifted now the double bond to carbon number 2. And then we do the same. Make sure that around each carbon there are 4 bonds. 1, 2, 3, 4. 1, 2, 3, 4. On this one, 1, 2, 3, 4. On this one, 1, 2, 3, 4. On this one, 1, 2, 3, 4. And then you put the hydrogen atoms. There will be 10 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so this is on carbon number 2. So when you're reading it again, you say pent 2 E N E. So even if you brought it this other side, you start from here, you bring it here, it will still be on carbon number 2. And so I thought this is very important because before we look at how these actually alkenes would react with other compounds, we need to know how to write their molecular formula as well as their structure formula. So next time we'll look at how alkenes can react with other compounds, having in mind that you by then would have already learned, would have understood how to write the structure formula and the molecular formula for alkenes. So for you to continue getting these testing lessons, ensure that you subscribe to my YouTube. I thank you.